Hello. In this video I'm going to show you how to compute the sample mean, variance, and standard deviation with a set of hypothetical data. So we have raw scores on a measure of self-esteem, which we are going to just call variable x. So we have raw scores for 7 individuals. And what we're going to do is start off by computing a sample mean using the formula for sample mean right here. So the formula for sample mean is denoted as sigma x divided by n. Now, in the context of statistical notation, the sigma is representing a summation operator. So basically what you're saying is sum the scores on x. So anything to the right of the summation operator is something that you sum. The n that you see within the formula is the sample size. So simply put, the mean is computed as the sum of the raw scores on x divided by n, which is your sample size. So let's go ahead and do that. And we're using SPSS, but obviously you can calculate this by hand if you want. So what we'll do is we're going to sum up all of these values in this column B. So I'm just going to say equals sum and sum these up. And so the sum of the scores on x is 42. So to compute the mean, we are just going to divide by the sample size, which is n in this cell right here. So I'm just going to say equals this number divided by the sample size, and that gets us a mean of 6. Now just FYI, if you're working with Excel, you can do this a lot quicker just by using the average function. If you say average and then all of these cells right here, then hit enter, you can see that you get the same number. Okay, so the next thing that we're going to look at is the variance for the scores on x. So the variance formula, first off, the sample variance is denoted as s squared. And the formula may look a little scary, but it's not really once you break it down. First off, let's look at the information or the portion of the formula within our parentheses. You'll notice that it says x minus x bar. And basically, when you do this, you're calculating deviation scores. So you're deviating each raw score from the mean on the variable. Okay, so the next step is to square those deviation scores. So that's where the squaring comes in. And then finally, you're going to sum them up. So what happens is that the numerator of the formula is effectively called the sum of squares for x. When you take the sum of squares for x and divide by the sample size minus 1, you get the sample variance. So let's do this now using our little table. So over here I have x minus mean, so we're computing deviation scores. So what I'm going to do is just type in equals raw score on x minus the sample mean, which was 6, and that gets us a -3 for the first observation. That means that the first person is scoring 3 raw score units below the mean on x. We can do the same thing right here. We'll just say equals 4 minus the mean, which again is 6, which is -2. Obviously, if we take 6 minus 6, we get 0. So in other words, this person obviously is scoring at the mean on that variable. If we do 7, we will see that that person is scoring 1 unit above the mean on x. So there's obviously a quicker way of doing this, and that is just to I'm just going to use B14, cell B14, and lock it, hit enter, and then I can just drag this all the way down, and there you go. So now we have all of our deviation scores on x. So the next column, we have the square of those deviation scores. So we can do this just by typing in equals -3 and then squaring it by adding in a caret and then 2 right here. So now we see that our squared deviation score for the first person is 9. And then obviously we can do that the same way for each of the remaining persons with respect to their scores on x. So now we have all of our squared deviation scores, and then the final step in the numerator of the variance formula is to sum it, and that's what provides us with the sum of squares for x. So to do this, I'm just going to say equals sum all of these values within this column and hit enter, and so now you can see that the sum of squares for x is 28. And I can obviously do this quicker as well, just by typing in equals sum SQ, and then I'm going to highlight all of the values, the deviation scores that we just calculated, and there it is. So next we're going to finish up by calculating the variance. The variance is the sum of squares for x divided by n minus 1. So to accomplish this, we can just type in equals the sum of squares for x, divide that by the 7, which is our sample size, n, minus 1. So that's obviously going to be a 6. Then I hit enter, and so now I have the sample variance is 4.667. I can also calculate this quicker as well if I just use, if I type in equals var dot s and then highlight all of my original raw scores in this column right here and hit enter, and there it is. Now the sample standard deviation is nothing but the square root of the variance. So you'll see it oftentimes reflected when standard deviation is being reported. You might see it reported with a small s, but formulaically you can see it's the square root of the variance, so it's the square root of this number, or we could just basically put this entire portion of our variance underneath the radical, and that gives you the sample standard deviation. You can obviously move back from the sample standard deviation to the variance just by squaring the sample standard deviation. So what I'm going to do here is go into standard deviation, and we'll just say equals square root of our variance, and there it is. Obviously in Excel you can do this quicker as well. You can just basically say stdev.s and then highlight the values in the x column right here and then hit enter, and we get the same number. So that's basically all there is to it. If you would like a copy of this spreadsheet, I will make it available as a link underneath the video description, so be sure to download it, and I appreciate you watching.